Good morning. Myself Karpagam, working as an assistant professor in the Department of ECE at Hindustan College of Engineering and Technology, Coimbatore. So, in today's class, we are going to discuss about the subject called circuits and networks. Under that, we are going to discuss about the topic Thevenin's theorem. So, the contents are the statements of the Thevenin's theorem and example problem and its solution. Statement of the Thevenin's theorem. The Thevenin's theorem states that any kind of complex linear network can be replaced into its equivalent circuit with a single voltage source and a series resistance. So the diagram shows the equivalent circuit of the Thevenin's theorem. So in this we can see that multiple resistive circuit elements are replaced by a single equivalent resistance, that is Rs, and multiple energy sources by an equivalent voltage source called Vs. So we will see about the step-by-step procedure of the Thevenin's theorem. The first step is remove the load resistance RL, and the second step is to find the open circuit voltage, that is V Thevenin, which is across the two terminals where the load is RL, that is RL is removed. And the step 3 is we have to replace all the voltage sources by their internal resistance. And step 4 is to calculate the Thevenin's voltage by looking the resistance R Thevenin from the load terminals. And fifth step is replace the entire network by the open circuit voltage V Thevenin in series with the equivalent resistance R Thevenin. And the step 6 is connect the load resistance RL where it was already removed from the circuit. And the seventh step is to find the current in the load resistance RL. So the formula is IL is equal to V Thevenin divided by R Thevenin plus RL. So here IL represents the load current. So we will discuss the Thevenin's theorem easily along with one simple problem. So to find the problem is find V Thevenin and R Thevenin and the load current IL flows through the load voltage across the load resistance in the circuit given below. So here 48 volt represents the battery and 12 kilo ohm and 4 kilo ohm resistance are connected in parallel, and as it is 4 kilo ohm and 8 kilo ohm are connected in parallel, and RL represents the load resistance, that is 5 kilo ohm. So the problem solution is the first step is to remove the 5 kilo ohm resistor from the circuit. Here 5 kilo ohm represents the load resistance RL. And step 2 is to measure the open circuit voltage, so from that is represented as V Thevenin. And step 3 is we have to calculate the Thevenin's voltage by determining the current that flows through the 12 kilo ohm and 4 kilo ohm resistor. Here both the resistors are connected in series. The current that flows across them can be calculated as follows. So I is equal to V by R. So V represents the total voltage, that is 48 volt, and R represents the total resistance. So here we know that we already removed the 5 kilo ohm resistor. So remaining two resistors, that are 12 kilo ohm and 4 kilo ohm, they are connected in series. So we should not consider the open circuit voltage resistance 8 kilo ohm, as there is no current flows through that resistance which is connected across the terminals AB. So I is equal to 48 volt divided by 12 kilo ohm plus 4 kilo ohm, which will give the total current, that is I is equal to 3 milliamps. So therefore 12 volt will appear across the AB terminals, hence the Thevenin's voltage will be represented as V Thevenin is equal to 12 volt. And step 4 is short circuit the voltage sources as shown in the figure. Step 5 is to calculate the Thevenin resistance by measuring the open circuit resistance. So here we know that 8 kilo ohm resistor is in series with the parallel combination of 12 kilo ohm and 4 kilo ohm resistor. So, by the formula, we know that if the two resistors are connected in parallel means the formula is R1 into R2 divided by R1 plus R2. So, here R1 represents the 4 kilo ohm resistance and R2 represents the 12 kilo ohm resistance. So, R Thevenin is equal to 8 kilo ohm plus 4 into 12 plus divided by 4 plus 12. So, by solving this equation, we will get the R Thevenin value, that is equal to 11 kilo ohm. And step is 6 is to connect the R Thevenin in series with the voltage source V Thevenin and the load resistor as shown in the figure. So step 7 is, this is the last step. So in this step we are going to calculate the load current by using Ohm's law. So we know that I is equal to V by R. So load current is represented as IL, that is equal to V Thevenin divided by R Thevenin plus RL. V Thevenin represents Thevenin's voltage and R Thevenin represents the Thevenin's resistance and RL represents the load resistance. So by substituting the values of V Thevenin, R Thevenin and RL, we will get the load current, that is equal to 0.75 milliamps. So thank you.